In this video, we're going to define and talk about reference angles. In our next video, we'll actually compute some reference angles and go through some examples. Let theta be an angle in standard position that lies in a quadrant. All right, so we're starting with an angle theta, and all I know about that angle is that it's not quadrantal. It doesn't lie on one of my axes. Its terminal side ends up in a quadrant. The reference angle for theta, which there are three different notations we'll talk about for it. Theta bar, which is just theta with a line on top of it, theta prime, and theta sub r. Those notations get used interchangeably. They show up just as often as each other in mathematics. If you're watching this video as part of a pre-calculus trigonometry course at Alamance Community College, our textbook actually uses the theta prime notation, while I prefer the theta bar notation. All right, well, that reference angle for theta is the positive acute angle formed by the terminal side of theta and the x-axis. Well, if I take this terminal side, there are only two ways to go to get to the x-axis, and only one of them would be an acute angle. Always the smaller of the two possibilities. By definition, this reference angle is acute and positive. And there, for that example, we see it, that would be the reference angle. So I have four angles drawn here, and I'm imagining that these angles live on that first full revolution. My angle is between 0 and 2 pi. And here I have a nice, happy first quadrant angle on that first full revolution, and the reference angle is supposed to be, well, positive acute angle between that terminal side and the x-axis, which means that a first quadrant angle on that first full revolution is its own reference angle. Well, the way I've written this definition, that's perfectly fine. Theta bar is equal to theta. I have to admit that some textbooks say to have a reference angle, your angle can't be acute. I like every angle to have an acute angle. I prefer definitions that are as broad as possible. So here for these first quadrant acute angles, I just say the angle is its own reference angle. Moving over to a second quadrant angle on this first full revolution. This is that example we already saw. But what I want to do now is come up with an equation like this where I could read it, the reference angle is equal to something. So I guess for this one, what I'm really thinking about is that theta bar is the same thing as theta. Well, I can observe here that if I add theta in its reference angle, that I end up all the way over here on the x-axis again, making that a straight angle, making that pi radians or 180 degrees. Solving for theta bar reveals that I could compute that by saying pi minus theta, or if I was in degrees, 180 degrees minus theta. Let's use that same logic to come up with equations like these for third and fourth quadrant angles. In fact, I challenge you to pause the video here and see if you can deduce what they would look like. Okay, so I see my reference angle here. I'll call that theta bar, right? This nice, happy, positive acute angle between the x-axis and that terminal side. And what I'm going to observe is that if I went pi radians and then theta bar more, I've ended up at theta. So I could write that theta is the same as pi plus theta bar. Taking pi away from both sides, I get theta bar is equal to theta minus pi. And if I wanted to work in degrees, theta minus 180 degrees. And so there's that relationship. And now I have one more reference angle to worry about. And there is theta bar. And what I'll think about this time is if I went one full revolution, 2 pi radians, I've gone too far and I need to back up by theta bar. So theta bar, well, let's do it that way. My angle theta is equal to 2 pi minus theta bar. Getting theta bar by itself, I see that that is theta bar is 2 pi minus theta, or if you prefer degrees, 360 degrees minus theta. All right, in our next video, we will calculate some reference angles for specific examples, including examples that go further than one full revolution.